Hello, this is Matt from Matt Heaney Apps, and this is part 6 in our full game tutorial series teaching you how to make the full iPhone game Solo Mission in Xcode using SpriteKit and Swift. Before we begin, quick bit of news. This was going to be the final part in this series, but once this entire video was recorded, it was way too long. So I've broken up everything that's left and put it into 2 parts. So this series is now a 7-part series ending next weekend. Okay, because this video was going to be almost an hour, it was just way too long. So in this video, we will set up our start of the game sequence and our scrolling background, and then next time we will do our main menu and our backing audio to wrap the entire project off. So by the end of this video, your game will look like this. Okay, so let's jump back into Xcode to continue. Okay, so back into Xcode and back into our GameScene.Swift. Today we will begin by setting up our start of the game sequence. So at the moment, when you are taken into the game scene, the game starts straight away. So straight away, enemies will start coming down at you and you have to start firing bullets at them straight away. So that's alright, but we can do it better. So what we want is a start of the game sequence that will look like this. Okay, so when you're taken into the game scene, you will have to tap the screen to start. When you tap the screen, the player ship will move onto the screen and you can start the game. So with this, when you are taken into the game scene, you have to tap the screen. When you do tap the screen, the player ship will fly onto the screen into position and the enemies will start coming down at you. Okay, so that will be the start of our game. So we will now set up our final game state, our pre-game. So the first thing we have to do is change the start of our game scene, so when you move into the game scene, it looks like this. You'll have an extra label and the player ship will not yet be on the screen. It'll be underneath the bottom of the screen waiting to fly in. So to set that up, into our did move to view, and we have to change the player's starting position, okay, because it has to start underneath the bottom of the screen. So we will change the Y coordinate to be underneath the bottom of the screen. So the Y coordinate will now be 0 minus player.size.height. Okay, so find the bottom of the screen and take off the height of the player to make sure it's always underneath the bottom of the screen. This will be the exact same thing as this saying minus player.size.height. I personally like doing 0 minus player.size.height. Exact same thing. So the player now starts off the bottom of the screen. We also need a label that will say tap to begin, which is going to be global because we will be affecting this in a few places. So let tap to start label, so an SK label node with the font named the bold font, and we will set this up in our did move to view. So we will say tap to start label and we'll give it some text that says tap to begin. It will have a font size of 100, a font color of white, a Z position of 1, and an actual position in the center of the scene. And then we can simply add it. So our game scene now looks like how we want it to look when we first move into the scene, so before the game. However, just because we added a label and moved our player ship so you can't see it, that's not enough, because the code is still going to be starting the game straight away. So what we have to do is, in a did move to view, get rid of the start new level line, because we no longer want to start this level straight away. We'll be calling that later on when we start the game. We also have to now tell our code that our starting game state is now pre-game rather than in-game. So our code will now know that we are before the game and it will know not to start the level straight away. Okay, so now our game will not start straight away, our player is off the screen and we have our label telling us to tap to begin. So hit run and let's check that out. So now when we move into our game scene, the game does not begin and it will tell us to tap to begin. The player ship is not yet on the screen because when the game begins, we want it to fly onto the screen. So before we move on to actually setting up the start of the game, this here, it looks alright, but we can polish it a little bit more. This is just a few really small details, but as I always say, I think they make a massive difference. So at the moment, when we move into our game scene, these 3 labels are just sort of there. what we want to do, we want the tap to begin label to fade in, and we want the score label and the lives label to sort of fly onto the screen. Okay, let's jump back into Xcode and I'll show you what I mean. Okay, so when we move into the game scene, this is what we want to happen. The label that says tap to begin will fade in, just really quickly, but it will still fade in, and our score label and our lives label will move in from the top of the screen. So, all we have to do is find our tap to start label, and we will give this a starting alpha of 0. So alpha relates to the transparency of the object, so alpha of 1 is just normal, alpha of 0 is completely see-through. Okay, 0.5 is half see-through, 0 is completely see-through. So it will start off in position but invisible. So what we have to do then is make it fade in. So let fade in action, so in sk action.fade in with duration, over a duration of 0.3 seconds, so just really quick. And then run that on the tap to start label. So now our label will fade in rather than just be in there straight away. Okay, so we gave it an alpha of 0, so it's completely see-through, and then we made it fade in over 0.3 seconds. For our labels, all we have to do is change their starting Y position, so they're just off the top of the screen. So this is for our score label and our lives label. For the Y, we'll find the top of the scene, and we'll add the height of the label to make sure it's fully off the scene and off the screen. So for a label, we will say score label, and to get the size of it, we'll say .frame, .size, .height. I will close the side panel so it's on one line. There we go. So take our score label and give it a starting position off the top of the screen. Okay, so for the position, find the top of the scene and add the height of that label. We've only changed the Y coordinate, so the X coordinate stays the same. Same with our lives label. So find the top of the scene and add the height of the label. Now both of our labels will start above the top of the screen, and then all we have to do is make them move onto the screen. So let move onto screen action, it's going to be an sk action dot move to Y. So this is an action to only affect the Y coordinate, so to make the labels just move down. The X coordinate is already correct, so we've only got to change the Y coordinate. And the Y coordinate we want it to be is what it was originally, so self.size.height times 0.9. So that was the Y position of the lives label and the score label over a duration of 0.3 seconds. And then simply run this action on both the score label and the lives label. Okay, so now both of our labels will start above the top of the screen and will then move on. So that will be happening whilst our tap to start label will be fading in. So very tiny mini transitions for each of our labels. So now that we've set that up, you can run this and test it now, but at the moment, because we're moving straight into the game scene, this all sort of happens as the actual game, as in the app, is loading up. So the first time you run it, you don't really see it happening. But later on, when you move from the game over scene back into the game scene, it will work fine. And in part 7, we will have a main menu, so we won't be taken straight into the game scene, so that won't be a problem. But if you want to check it out now, go ahead and check it out. But I would wait until after we have set up the game actually beginning, because then you can get game over, move back into the game scene and see it properly. But it's up to you. Okay, so that is that polished off. What we now have to do is deal with starting the game when the player has tapped the screen. So, brand new function called start game. So in here, we'll have all of our code to deal with moving from this pre-game state into our actual game. Because now that we have this start of game, our code understands that the current game state is before the game. Okay, so we have to deal with changing this game state and making the game actually begin. But before we do that, what we're going to do is jump into our touches began, where we will deal with triggering this code to make the game begin. So at the moment we're saying if the current game state is in game when we touch the screen, fire a bullet. What we also want to say now is if the current game state is before the game, so .pregame, then we want to trigger start game. Okay, so we touch the screen whilst we're before the game, start the game. If we're in the game, when we touch the screen, fire a bullet. What we want to do here is change this one to be an else if, because in start game, we'll be changing the game state to in game, and if this is not an else if, then we're going to get a bullet firing the first time. Okay, because we'll be changing game state to in game in here, it will read down like a book, and because by this stage, game states will equal in game, it will fire a bullet. With an else if, the first time we tap the screen to start the game, it will not fire a bullet, which is exactly what we want. So now, if we touch the screen whilst in this pre-game situation before the game, we will run the code start game. So, what do we want to happen when we start the game? Well, we want to change our current game state to now tell our code we're in the game, so we can now fire bullets and move the ship. We want to make our tap to start label fade out and delete, so let fade out action, so be an skaction.fadeout with duration across 0.5 seconds. We want a delete action, which would remove the label entirely, and a sequence, which will then make our label fade out and then delete. So we run this on the tap to start label. Now, when we start our game, our label that says tap to begin will fade out and it will then be deleted. So we have no need for this label anymore, so get rid of it, because we're now in the game. What we also want to do is make our player ship move onto the screen, and when it's on the screen, start the first level. So with actions, we'll call this the let move ship onto screen action, then skaction.move to y. So again, only affects its y coordinate, so where it is up and down the screen. And the ship's original starting position was self.size.height times 0.2. So this is where we did have it before we changed it for our starter game sequence, across 0.5 seconds. We also want an action to start our level, because remember, to start a level, we have to run the function start new level. So this from way back when, which was originally being called in our did move to view. So let's start level action. It's going to be an skaction.runBlock, and we're going to run our function start new level. And we will set these up as a sequence. So we don't want our level to begin until the player ship has moved fully onto the screen. So let start game sequence. It's going to be an skaction.sequence, where we will move ship onto screen action, and once that's finished, we will start level action. And then we'll take our player and we'll run this sequence. So now when we start the game, we are going to move the player ship onto the screen, and then we will run the code to start the first level to start the game. So now when we tap on the screen, when we're in this pre-game state, we're going to change game state so our code knows that we're now in the game, make our label that tells us how to start the game, make that fade out and delete, move our ship onto the screen, and then start the first level. Okay, and that is running when we tap on the screen when we are in the pre-game game state, which is before the game. Okay, so just with that, we now have our start of game sequence. So hit run. So now if we tap on the screen, our player ship will fly in and the game will begin. Now at the moment there's a little pause before the enemies start coming down, and it feels like quite a long pause. But I think that works because it gives them a second to kind of get used to dragging the ship around and firing bullets. So it's almost a mini in-game tutorial. It just gives them a chance to kind of figure out what's going on. But it feels like quite a long pause because nothing at all is happening. So let's make something happen. When the game begins and our player ship flies onto the screen, we will have our background start to scroll. So at the moment, the start of our game feels very static, feels very still, but that won't be the case when we set up our scrolling background. So let's jump into Xcode and we will set up our scrolling background. Okay, so back into Xcode and back into the GameScene.Swift. So we will now set up our scrolling background. Fair warning, a scrolling background I think can be one of the hardest things to get your head around when starting out making games in SpriteKit. It's not that bad. I think it's one of those things where you first look at it, it's quite scary because there's quite a bit going on. So the following section, you might have to watch a few times to get your head around entirely. So I'll do my best to break it all down as much as I can, but if you get a little bit lost in the next section, completely understandable. So before we set up our scrolling background, let's have a look at how a scrolling background is going to work. Okay, so this is how we set up a scrolling background. I'll explain it all now, and then we will break it down fully as we go through the stages to actually set this up. So we are going to create two different backgrounds. One that starts fully on the screen, and one that starts above the top of the screen, as our background will be scrolling down. We are then going to move both backgrounds at the same speed at the same time. We will do this with manual movement rather than actions, so we have more control, and so we can easily change the speed of the background at any time. Manual movement involves moving the backgrounds a tiny bit, a lot of times, which will make the background look like it is moving smoothly down the screen. When one of the backgrounds has left the bottom of the screen, we will move it to back above the top of the screen, where it will move down again, giving the illusion the background is constantly scrolling. It will make our background look endless, even though it's just two backgrounds. So to make the backgrounds move, we will move them both down a tiny bit over and over and over again very quickly. We will do this in the update function, a function that runs once per game frame. So every time the game scene renders, the update function will run. The update function is at the start of what is called the game loop, the process that happens once per game frame, which ends with the scene being rendered, which sort of recreates your scene with any changes of stuff moving or doing, well, anything. This is what FPS is, your frames per second, and that's why it's so important. The more frames you have per second, the higher the amount of times the game loop runs, the more often your scene gets rendered, which, as the update function is part of, is also the number of times the update function runs. So basically, the higher the number, the smoother your game looks. This should be running 60 times per second on iOS devices, because the highest frames per second you can run at on iOS devices currently is 60 frames per second. However, you don't always run at 60 frames per second. Sometimes your game can drop down to 59, 58 or even lower, just for the odd second or two every now and then. So we have to take that into account when moving the backgrounds, because if we move the background a set amount per frame, and then the number of frames per second varies, the background moving will look jagged and it will just look weird. So, what we have to do is figure out the amount of time between each background's tiny movement, and move the background a correct amount depending on this time to make it look as smooth as possible. Because of this, we have to calculate the time between each frame to move the background the correct amount to ensure the best results. So basically, we will move two backgrounds a tiny amount depending on how quickly the game is running in terms of frames per second, and when a background leaves the bottom of the screen, it will move back to above the top of the screen to allow the process to continue. So, we need to set up two backgrounds, both of which we will move using manual movement, using the update function, working with the time that has elapsed between each frame. So, let's break this all down and do this one stage at a time. The first thing that we have to do is set up two separate background images. So into our did move to view, and to where we set up our background. Now we need two of these, and apart from the position, they're going to be absolutely identical. They'll be exactly the same. So we could have let background 2 equals the same thing here, give it the same size, same Z position, but we don't want to do that. It's pretty much copying the same exact code. To do the same exact thing, we want to run the same code twice to make both of our backgrounds. So find all of your code for your background, and we will run this in a for loop. So for I in 0.1 open curly bracket, and the closing curly bracket will go after all of our stuff for the background. Okay, so this is a for loop, and what it is saying is run the following code, so the code between the curly brackets for the for loop, a certain number of times. And what's going to happen, every time this runs, this will take whatever we have here, so we have called this I for the loop index, and I will start at a certain number. And then every time this code runs, it will add 1 to I and run it again until we've reached a certain other number. And that's what this is here. We're saying, to start with, make I the number 0, and then run up to and including when I is 1. So now, I will start at 0, all of this code here will run, it will get to the end, and it will start again. It will then add 1 to I, so now I will be 1, so from 0 to 1, and it will run again. The same thing will happen, back to the top, and it will then add another 1 to I, so it then equal 2, which is too high. We said stop after you reach the number 1. So the loop will then finish, and we will move on. So basically, this code here is going to run twice. Once with I being 0, our starting number, and once with I being 1, our ending number. Say for example we had this at 10, this would run 11 times. Okay, so starting at 0, run it, add 1 to 1, run it, add 1 up to 2, run it, add 1 up to 3, run it up to 4, run it up to 5, up to 6, up to 7, all the way up to and including 10. So 11 times, including 0 and 10. Okay, so that's what these numbers here are. This is our range. So this code here will now run twice. We're going to get 2 backgrounds. So we now have to position these 2 backgrounds differently. So we have one starting fully on the screen and one starting above the screen, because it will scroll down onto the screen. So what we're going to do, we will change the background's anchor point, which is the point of the image that relates to the position that we set. So as you can see from this picture here, by default the position that we set is the center of the background. That's the default anchor point, the center of an image. We could leave it there, but to make it a lot easier, we will change the anchor point to be the bottom of the background. It will then be a lot easier to position our backgrounds and to see when a background has left the bottom of the screen, so we can move it back to the top of the screen. So we say background dot anchor point, and this is a CG point because it needs an X and a Y, with the anchor point's bottom left of the image being 0, 0, top right being 1, 1. So we will keep the X in the middle and put the Y anchor point down at 0. So the position that we set our background would now be the bottom center of the background. Why does that make it easier? Well, it makes it easier when it comes to placing our Y position. So let's break up our CG point for a position a little bit. So what we're going to do is use this I. Use the loop index. So we will set Y depending on what the index of the loop is. So now the anchor point is the bottom of the background. The Y coordinate of the first background will be 0. The Y coordinate of the second background will be the top of the screen. So the same value as self.size.height. Okay, so one's at the bottom of the screen, one's at the top of the screen. But because that anchor point is at the bottom of the background, it will sit nicely just above the top of the screen. So for the Y, what we're going to do is we will take self.size.height and we will times it by a CG float version of the index of this up here. Okay, so I need a CG float to format it into a decimal so we can times it by the height of the scene. Okay, so what we've done now is said, when we run this the first time, and when I equals 0, set the Y to be the height times by 0. Okay, so anything times by 0 is 0. So the Y coordinate of the first background is now 0. We times our height by 0, so it's now 0. The second time round, I, the index, will equal 1. So the Y is going to be set to self.size.height times by 1, which is equivalent to just saying self.size.height. So we've now run the same code twice, positioning our 2 backgrounds in different places depending on what I is. Okay? First time round, I equals 0, put our background at the bottom of the screen, so it covers the entire screen because of our anchor point. Second time round, when it's 1, again because of the anchor point, now position it at the top of the screen so it sits above the top of the screen. Okay? Hope that makes sense. So we now have 2 backgrounds. After I did move to view, we will set up our update function. And this function here is going to run at the start of every game loop. So once per game frame. So this function here could run up to 60 times per second. It's running once per frame. And here we will move our backgrounds a tiny amount. But because it's running so often and our backgrounds will move that tiny amount so often, it will look like our backgrounds will move nice and smoothly. And when it runs, we're being passed the time right now. So what we have to do is figure out the time now, so current time, and figure out how much time has passed since the last frame. So we're going to figure out the delta time between frames. We'll then use that to figure out how much to move our backgrounds. And you do backgrounds this way instead of with actions because you have so much more control. Which will make sense as we go, I promise. So, we already have current time, so the time right now. What we need globally, so outside of a function, is a variable called last update time. It's going to be an ns time interval, so a number in seconds, and we'll give it a starting value of 0. And we will use this to store the time of the last frame. We will then compare that to the current time to figure out how much time has passed. And how much time has passed is called delta time. So delta frame time. Again, it's an ns time interval, could be dealing with seconds, and start off at 0, so 0 seconds. So now with all of this, we can figure out the difference in time between updates. We can then use that to figure out how much we have to move our background. So, what we're going to do is every time we run update, at the end of this function, we will store current time as last update time. So the next time this runs, the time that was current time last time is now last update time. Okay, we have to prep this to figure out delta time in the right way. So we're going to say if last update time, if that is set to 0, then this has not run yet because last update time, when we initialize it, is set to 0. That's why these are being declared globally, because we don't want to initialize them and set them back to 0 every time we run an update. We only want to set these to 0 once. That's why they're global. So if last update time equals 0, this is the first time this has run, so we can't figure out the difference in time. Because this is the first time it's run, so we have nothing to compare it to. So what we're going to do is take last update time and set that to current time. So take our variable last update time and set that to match the time now in our game. And if that's the first time this has run, that's all we want to do. You can't figure out the time elapsed between 2 frames if it's the first frame. But if that's not the case, and last update time does not equal 0, therefore we have a time in place, therefore we can figure out delta time. So we will take delta frame time, this one from here. So this will equal the difference between the time right now and the time of the last update function. So it's going to equal current time, the time now, take away last update time. What we then do, once we figured out delta time, we will update the value of last update time to match the time now. And that is figuring out the delta time between frames. You're going to see why we need to do this in a second. So to quickly review, what we're doing is we are using the update function, a function that runs once per game frame. So it should hopefully be running somewhere between 58 and 60 times per second. And we will use this to move our background by moving it a tiny amount over and over and over again very quickly. And to move our background the right amount, we have to figure out how much time has passed between the last time this ran and this time this ran. So this here is figuring out how much time has passed between the last update and this update. So why is that so needed? Because what we're going to do is say how much we want our background to move per second. So var amount to move per second is going to be a CG float. And here we're going to say how many points we want our background to move per second. So we will set this to be 600. So our background is going to move 600 points down the screen per second. It's going to be pretty quick. As a quick audio edit, this here should have been let because this value will never change. However, with this being var, you will be able to see the real control you have over your background using this method. Because by changing this number here at different points throughout your game, you can really easily affect how quickly the background is moving. So literally all you have to do is change the value of this here by changing its number wherever you want to change the pace of the background scrolling. I was going to show you an example of this, but due to the length of this video, I didn't want it to be too long. I had to cut it out to focus on actually setting up the scrolling background. But it's still a really important skill for you guys to know about. So that is why this was a var. But when this is set up, play around with this and change this number at different points throughout your game to see the impact it has on your background, to see the real control that you have over your background with manual movement over actions. So now that we have the difference in time between the updates, what we can do is say let amount to move background, and this will equal amount to move per second times by a CG float version of delta frame time. So we said we want our background to move 600 points per second, and we figured out how much time has passed in each of these updates. So it should be about 0.02 of a second. So what we're doing is taking that 0.02 of a second and converting it to be 0.02 rather than 0.02 seconds, and timesing it by amount to move per second. So a bit more of a straightforward example. If we're running at 2 frames per second, but obviously in real life you would never ever be running it anywhere near that low, and the amount of time that has passed in the update function since the background moved last time was half a second, 0.5 seconds. What we've done is times the amount to move per second, which is 600, and times that by 0.5. Amount to move background would now equal 300, and that's how much we have to move our background by. So to figure out how much we have to move our background, we've taken amount to move per second and times it by how much time has passed. We can now move our background the right amount depending on how much time has passed between frames. So amount to move background now stores how much we have to move each of our backgrounds. What we now have to do is affect the Y position of each background by the value of amount to move background. Now just like last time with our bullets and our enemies, we can't get straight access to background because it's not global, but we also can't make it global because we need 2 of them. So we have to declare it within this loop so it gets declared twice. So what we're going to do is give it a name, just like we did with our bullets and our enemies, and then we can make a list of all the objects with this name, so we can then affect all of our backgrounds. So we have 2 backgrounds, we affect both backgrounds. So into the update function, and once we figured out how much we have to move our background by, we will generate a list of all the backgrounds. So make sure this here matches the name we gave our background. So this here matches this here. So we've now generated a list of all the objects with the name background. If you're a little bit confused by the enumerate child nodes with name, I explained that in a lot more detail in part 5, so check that out there. What we'll now do is cycle through this list, we call it background, and we can now affect background, so an object from this list, we can affect its Y position by taking off amount to move background, this from here, which is taking how much we have to move per second, timesing it by how much time has passed to figure out how much we have to move our background by. And because we're doing this with our list, this will affect both backgrounds in the exact same way. All we have to do now is say when a background has left the bottom of the screen, move it up to the top of the screen to keep the background scrolling. Okay, so once it's left the bottom of the screen, move back to the top to move back down onto the screen, which will give the illusion of an endless scrolling background. So if background.position.y, if this is less than minus the value of the height of the scene, because of our anchor point, this would mean the background has left the bottom of the screen fully. If that's the case, move it back into its new position by taking background, taking its .y position and adding 2 lots of the height of the scene. So as soon as it leaves the bottom of the screen, add 2 lots of scene heights to it to put it back to the top of the screen it will then move back down and it will continuously scroll forever and ever. So that's our scrolling background. I hope that all makes sense. I think that's a hard thing to get your head around. But we'll go over it again now, and hopefully it make more sense to you now that all of the code is there. So we said to start with, run a loop so we get 2 backgrounds. Okay, so we now have 2 backgrounds instead of just 1. We then said we want to affect both of these by moving it just a little bit every time the update function runs, which could be up to 60 times per second. Okay, so the update function runs every frame. So frames per second is how many times this update function is going to run, because this update function is part of the game loop, which happens once per frame. So we've said we want to affect the background's movement ever so slightly every time this runs. But because we don't know how much time has passed between update functions, so between frames, we had to figure it out. We don't know how much time has passed. So we had to figure out how much time had passed between each frame. So between the last update function and this update function. So we had to figure that out as delta frame time. We then said we want this background to move 600 points per second. So that's how much it should move per second. We said figure out how much time has passed, times that by how much we want to move per second, to figure out how much we should have moved in the amount of time since the last update function, and then move the background that amount. Okay, so if half a second had passed between these 2 update functions, move the background the amount that it should have moved in half a second. Okay, so we're using our reference of how much it should move per second to figure that out. So move the background the amount it should have moved, and if it leaves the bottom of the screen, bump it back to the top of the screen. Now we haven't given this a set value of where it can go to. We've added 2 lots of the height of the scene to it. Sometimes the background moves just a tiny bit too far, and if we just give it a set value, when it moves down, there'll be a gap between the backgrounds. So if we add a set amount to it, rather than just putting it back in a set place, even if there is a tiny gap, doesn't matter because it won't be bumped up as far. So we're taking into reference that tiny little gap. Okay, so that's our scrolling background. So what we now have to do is polish this off just a little bit so it works the way that we want it to work. Because this will make our background work as a scrolling background. And it will give the illusion that our spaceship is moving through space. But we only want the background to be scrolling whilst the game is in play. So what we're going to do is we will find the line that moves our background, and we will throw this into an if statement that says if current game state equals game state dot in game, then move the background. If not, do not move the background. Because we are in the enumerate child nodes with name block, we have to say self.currentGameState so it can find the current game state in the scene. But it still means the exact same thing. Only make the background scroll if the current game state is in game, so therefore the game is in play. And just with that quick addition, our scrolling background will now only be a scrolling background during the game. So after all of that, it's time to check this out. Hit run. So now in our game, if we start the game, our background will start scrolling. It looks like our spaceship is now flying through space, killing enemies. Makes it look a lot cooler, and when the game ends, the scrolling background will stop because the game is no longer active. If you are testing this on a simulator rather than an actual device, especially on an older computer, this might look a bit laggy, but on an actual device, it runs fine. So our game now has a start of the game sequence and a scrolling background. We will finish polishing this game off next time when we set up our backing audio and our main menu. But for this video, that is all. As always, thank you for watching. If you liked watching this video, which I really hope you did, make sure to hit that like button, hit subscribe, leave any feedback down in the comments, and I will see you next time. Goodbye.